There we go. Boom. So this is the longer form of a video I just put out on TikTok and posted to Facebook. But this is worth the extended time it's going to take to explain this. So this, of course, is my Wimshurst machine. And if you're unfamiliar with it, when you turn this crank here, there are two counter-rotating discs. It's pretty cool. It's actually a very clever apparatus. They have pulley system here connected to one disc, and you can see that the pulley is straight, meaning it's not twisted. And if you look very carefully back there, you'll see there's another pulley that's crossed. So when you apply a clockwise rotation to the handle, it causes the front plate to follow the handle clockwise and the back plate to go counterclockwise. Very cool. As you can see, there's a whole lot of brushes here, there, and everywhere all over this to pick up the charge that's generated by these moving plates. That charge is moved through metal connectors here on either side to these capacitors right here. They're Leyden jars, but I mean, that's just another name for a capacitor. As the charge develops in here, there is an outlet right here between these two movable electrodes, which is kind of cool. And as you run these up, doesn't take very much, you can develop a particularly high voltage. As many of you who have played with Wimshurst machines are aware. So that's probably going, oh wow. And of course it sends out an EMP, and it just freaked out my monitor and freaked out my touchless thermometer. Yay, that's always fun. But anyway, I was trying to reproduce an experiment that I just saw done on the plasma channel, where he applied what he called a ground to one of the electrodes, which was his body. He just grabbed one of the electrodes and put the other electrode near an open flame, and the flame was attracted to his hand. But he said that he was grounding out one of the electrodes. He wasn't. He wasn't grounding it out. He was adding himself into the system. In other words, his hand was the opposite charged electrode. It wasn't grounded at all. So anyway, I tried to replicate that experiment, and I had all sorts of problems with it. Just some of my armatures would break. The brushes weren't touching. And then when I got it, and I finally got the flame to do it, it wouldn't do what he was demonstrating in his video. And I couldn't figure out why. Then I had an epiphany. Guys, watch this. You're about to see the power of dark mode plasma. Okay? Actually, let me do this. When I get the electrodes separated at a reasonable distance, I'm going to count how many times, how many full rotations it takes to generate a spark. Watch this. 1, 2, 3, just over 3. And then it's about 2 turns after that. Okay? Not much at all. Okay, now I'm going to ground these out so there is no charge. Put them back and light the flames. Those are just ordinary birthday candles I've got set up on a scientific stand. And you can see how far away they are, maybe 1.5 inches from the electrodes, just barely. Now I'm going to do the same thing, and I'm going to count how many rotations of the handle it takes to generate a spark. Here we go. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And I'm tired. The epiphany moment came when I realized why I wasn't seeing a discharge. The flame is, of course, plasma. Plasma is, of course, extremely conductive. But I made the mistake in thinking that a charge could develop in the presence of plasma that would allow for a discharge between the two electrodes. Nope, that's exactly what doesn't happen the plasma, I'm sorry, the charge is traveling through dark mode plasma to the flame and then being discharged via the flame through, probably this top up here. I actually don't know exactly where it's being discharged, but those electrons are flowing free, and the charge that usually develops is clearly dissipating. That's cool. So all the astrophysicists out there who deny the electric universe, I'm sorry, they really need to change their thinking. And if I can use a vernacular phrase, they need to wake up. Because that charge right there that usually develops between those two electrodes is clearly being dissipated through dark mode plasma. Look at this. I've been turning it now for almost 10, 15 seconds. Still nothing. And as I extinguish the flame and begin to turn, 1, 2, 3, 4, 5. There we go. And we're back. Dark mode plasma discharge. Is it a real thing? You're darn right it is. That's just cool.